This assessment tells us that the formation of citrate from oxaloacetate and acetyl-CoA is a two-step process, two steps that we now know, an aldol addition reaction followed by a hydrolysis. The assessment asks us to draw a mechanism for this process. Let's walk through the mechanism for the first step of this process, the aldol addition step. We will start with our acetyl-CoA. We're in an enzyme binding pocket, so we have enzymatic acids and bases at our disposal. So the first step then is the base removing the proton from the alpha proton of acetyl-CoA. In solution, this would form an enolate. However, negative charges like that aren't very stable in a cell, so we'll use an enzymatic acid to directly protonate the oxygen, forming an enol intermediate instead. And we'll also form the various conjugate acids and bases from our enzyme binding pocket. This sets us up for our key carbon-carbon bond forming step. So the base in the enzyme binding pocket will take its proton back, and that will allow the enol to act as a nucleophile to attack the carbon of oxaloacetate. That's going to form the key carbon-carbon bond in our aldol addition step. That builds up too much electron density around carbon. The carbon-oxygen pi bond will break. Again, instead of forming an O- charge, we'll use the enzymatic acid to directly protonate that oxygen. And that will form the product of this aldol addition step. I'm going to move this CO2 minus group up here to make room for our new acetyl-CoA side unit. So this is the immediate aldol product. This is the product of the first step of the formation of citrate from oxaloacetate and acetyl-CoA.